Alright, so let's review this on the videos. Talk about CPU, and we talk about 3.06 gigahertz. Now we talk about matrix, right? Giga is 10 to the 9, which is 1 billion. So for example, if I'm talking about, if I have a CPU, okay, a computer has a CPU speed of, sometimes we call speed, right? Or sometimes we call frequency, right? Let's do 1 megahertz. So hertz is the unit. Hertz, right? A computer has a CPU speed of 1 megahertz. Okay. So mega is gonna be right there. It's 10 to the 6, 1 million, right? So meaning that, so this means what? 1 megahertz means 1 million CPU cycles per second, right? So now one cycle, right? One cycle could be, right? Could be an estimate of one instruction cost 1 CPU cycle. Now when I say one instruction, an example could be like load, right? Load, like you open the program, save the program, right? Add, right? Add, addition, subtractions, add, subtract, multiply, divide. So those could be instructions. Some instruction cost more than 1 CPU cycle. Like it could be, sometimes we say, hey, divide is gonna cost more, like divide costs 2 CPU cycle. Okay? Something like that. If I say add cost 1 CPU cycle, right? Now, if I just say I want to find, like when you do equal is like a sign, right? That is also an instruction, like you try to save, right? Like equal, right? Operator. Like if I have example, if the program, right? The program below, okay. The program below, let's say I want to say 5 plus 7 divided by 2, right? And assign that to be x, something like that. If I give an example of the program, right? So the question is, how long does it take to execute? Execute, I mean try to find the answer of that, right? The following program below. Okay. So how long does it take? Now, in order to calculate this, we say, hey, 1 megahertz, right? 1 megahertz mean what? 1 over 1 times 10 to the exponent of 6, right? Okay. That means for one instruction, right? Like this is like a time, right? Time, right? We can say t equals 2, right? So in order to, this CPU can execute, right? One instruction with 1 over 1 times 10 to the 6 second, which is equivalent to what? 10 to the 6 is. Now we're going to look at, if you don't know the metrics, this slide is going to show you micro 10 to the negative 6, because when it says 10 to the 6 divided by, when we put in math, it becomes 10 to the negative 6, right? And 10 to the negative 6 equivalent to, we just look at that, micro, right? So that means this CPU can execute one instruction within 1 microsecond, right? So when we look at this way. Now, how many instructions? So if the question is very simple, if the question doesn't have divide by 2, okay, then this is one instruction, this is second instruction, correct? So you're going to say, okay, for if we say x equals 5 plus 7, so it's going to be 2. This program has 2 instructions, and we said 1 instruction costs 1 CPU cycle. Okay? So that means I have 2. So what do we do with this 2? We said 1 microsecond means in 1 instruction it costs 1 microsecond, right? And 2 instruction is going to cost 2 microseconds. So that means this program will take, right, 2 microseconds, right? Now, if we just change this question to be x equals to 5 plus 7 divided by 2 now, right? How about this program? It's the same CPU, so this program will take what? So this 2 just coming from 1 times 2, right? 1 microsecond times 2. That's how we get that. So now, how many instructions now? So we said D1 actually take 2 CPU cycles. That means it's going to take 2 instructions. Correct? That means it's become what? 1 microseconds times 4, because we have 1, 2, and this costs 2, right? So this is going to change to 4 microseconds. Alright, so let's say another example. We know Halo, right? Halo game, right? It's a game named Halo. And has 1 tera instructions. Okay. How long does this same CPU, right, to execute this program, right? The Halo program. Alright. Now we already know that how to calculate to 1 instruction costs 1 microsecond, correct? So pretty much you have to get to that point, right? So 1 microsecond is 1 instructions times 1 tera, right? So 1 because it already gave you, right? It's not hard. It already gave you 1 tera instructions. So 1 tera, now just what you need to do is just change it's to matrix, right? Micro is 10 to the -6 times 1 tera is, if you don't know, yeah, it's matrix 10 to the 12. So it's like have 1 trillion instructions in that program, right? So, and then you just do the math, algebra, exponents, right? You're going to add the exponents. 10 to the 12. So -6 plus 12, what do you get? Yes, 1 times 10 to the 6. So how long does it take to execute this program? 10 to the 6 is 1 million seconds, right? Right. To run that game, 1 million seconds. So 1 million second, you know that you just divide by 6 if you want to change to hours, minutes, right? Divide by 60 tends to be, right. So if we say 1 million divided by 60, you get minute, right? That's going to take how many minutes to run the program, right? So we'll use calculator 1000000 divided by 60. So it's going to take about 16,066 minutes. I mean, this is an example. But if it's take that long, then nobody's going to buy that game. So that's why it's very important. This calculation is very important for game developers. They don't want to have too many instructions. They have to go back and reduce, right? Instruction. Make sense? So about, what, 16,666 minutes. See that? If you divide by 60, then you get hours and so on, right? Or you have to, that's why there's spec. When you buy the game, do you think they will support 1 megahertz CPU? No. Halo said the minimum CPU requirement is to be gigahertz, not megahertz. See that? That makes sense now. Old. 1 megahertz is very old. So it's going to reduce this time into a lot, right? Like 10 to the 3 more. So that makes more sense now. Let's come to the question that, hey, if I have old CPU, can I run the new game? Yeah, you can wait about 1 year. Now we understand CPU is like a brain of the computer, right? Or nowadays you can see CPU is also on your phone, on your tablets, everywhere, in your car or your refrigerator. Everything use CPU. Your smartphone, yeah, refrigerator too. Like smart, like the news refrigerator. Microwave, TV, set, they have that. Now RAM, we talk about RAM, random access memories, just like temporary, right? Location for your. When we start a program, when we start the computers, the computer pretty much just load the operating system into the RAM, right? The operating system itself is also the program with the instructions that we just mentioned earlier, right? Now, where do we install when we install the operating system? It's stored into the hard drive. That's why hard drive is bigger than the RAM. We can install a lot of program, apps, things like that. App is installed on the top of the operating system, but it's occupied a hard disk. And this is a secondary storage, right? And if you want to communicate out of the computer, you have what we call like the input and output ports, like USB ports. You can just connect your flash drive, external memory to, or your mouse, your keyboard is like a peripheral, right? Interface. Besides that, we also